Good evening all. Last class we have completed up to question number 20. This class we will start question number 21. Of all closed cylindrical canes, right circular cylinder is given which is closed and a given volume is 100 cubic centimeter. Actually cylinder given, closed cylinder whose cylinder's volume is given. So for us what is given volume? So volume equal to V equal to 100 centimeter cube given. Next find the dimensions of the cylinder with minimum surface area. So what does we have to minimize the surface area. To minimize surface area we have to minimize, and what we have to find dimensions of this cylinder means we need the value of R and we need the value of H. Clear? Solution. So what is volume of cylinder? Volume of cylinder equal to V equal to, we can consider as pi R square H. So volume of cylinder is given from, that is equal to 100. So from that we can find any one value of H or R. We are going to find the value of H. So H equal to 100 divided by pi into R square. H equal to 100 by pi R square. So what we have to minimize? We have to minimize the surface area. So what is surface area of cylinder? Surface area of cylinder. So surface area of cylinder equal to S equal to total surface area we have to calculate. So 2 pi R square plus 2 pi R into H. So we will substitute the H value here. H value we found that R 100 by pi R square. So our surface area in terms of R will be 2 times pi R square plus 2 into pi into R into H value is 100 by pi into R square. So we can simplify and keep. So pi and pi get cancelled. One of the R will cancel. So my S of R equal to 2 pi R square plus 2 into 100, that is equal to 200 divided by R. So this is our S of R, surface area equation in terms of R. So I need to minimize this surface area. So I need to find the critical points by derivating, finding the derivative, finding the first derivative of this S of R. So to find S dash of R, differentiate this with respect to R. So we will get S dash of R equal to differentiation of 2 pi R square equal to 4 pi R minus 200 plus 200 into differentiation of 1 by R is minus 1 by R square. Now we can keep this, simplify this to 4 pi R minus 200 divided by R square. It is the value of S dash of R. If S of R equal to 0, if S dash of R equal to 0, which implies we can write that 4 pi R minus 200 divided by R square equal to 0. So we are simplifying this means that is 4 pi R equal to 200 divided by R square. We can cancel this one time. This one will be 50. So R cube, R square will come this side, that will become R cube. Pi will come to denominator. So this implies R cube equal to 50 by pi. So R value equal to 50 by pi power 1 by 3. So this is the value of the R. Is the only critical point. Now I need to minimize the surface area. So I need to find second derivative. So first derivative is here. So I am going to find second derivative. That is S double dash of R. S double dash of R equal to differentiation of 4 pi R is 4 pi minus 200 is constant. Differentiation of 1 by R square is minus 2 by R cube will come. So again simplifying this, we will get 4 pi plus 2 in 200 into 2, 400 divided by R cube will come. So we have to substitute the R cube value here. So R equal to 50 by pi 1 power 3, or R cube equal to 50 by pi, that I am substituting here. I will get 4 pi plus, substituting 400 divided by R cube equal to 50, this pi will go to numerator. Anyhow this value is greater than 0. So greater than 0 means we can conclude that S of R is minimum, S of R is minimum at R equal to 50 by pi whole power 1 by 3. Now R value we found, so corresponding H value also we have to find, because we need to find the dimensions of the right circular cylinder. So substitute this R value into the equation. H equal to, already we have written H equal to 100 by pi r square. H equal to, we have written 100 by pi r square, that I am going to use here. So H value already we have written H equal to 100 by pi r square. So this r square value I am going to substitute here. So H equal to, I will write here, H equal to, we have written 100 by pi into r square. So substitute the r value here. So we will get 100 divided by pi into r value equal to 50 by pi power 1 by 3. Squaring means 2 power 2 by 3. Now we will simplify this. So 100 pi can be written as 2 times 50 by pi into, this can be written as, this 50 by pi power 2 by 3 will come to numerator, that will be written as 50 by pi power minus 2 by 3. Now we will simplify this. This 50 by pi came to the numerator, so 50 by pi power minus 2 by 3. Now this 2 will be outside, we can add these 2, that is 50 by pi into power 1 minus 2 by 3. So simplifying means we will get 2 times 50 by pi power 1 by 3 centimeter. So our radius equals to 50 by pi power 1 by 3 centimeter. H equal to 2 times 50 by pi power 1 by 3 centimeter. These are the dimensions of the given right circular cylinder. Next question 22. So question number 22, a wire of length 28 meter is to be cut into 2 pieces. Totally a wire, total length of the wire equal to 28. So we can write that total length of wire equal to, given the 28 meter, it is cutting into 2 pieces. One of the piece is to be made into a square. So first piece I am going to make as a square. Second piece I am going to make as a circle. So second piece will be made as circle. First piece will be as a square. So now what is the question given? What should be the length of the 2 pieces so that the combined area of square and the circle is minimum? So the combined area should be minimum. Like that, the combined area is minimum means what is the length of the square to be made and what is the length of the circle to be made. That is length of the piece to be made circle and length of the piece to make a square. Clear? So what I am going to take? I am going to take one of the piece as x. So considering the x is the length of the piece of the circle. So let x be the length of the piece. Let x be the length of the piece to be made as a circle. So if x is the piece to be made as a circle means the remaining length will be the length of the piece to be made as a square. So the remaining length will be, if x means total length equal 28, the remaining length will be 28 minus x. So the other piece will be, so the other piece will be 28 minus x. So one of the piece is x, another piece is 28 minus x. So x be the piece to be made as a circle and 28 minus x is the piece to be made as a square. So now we are going to find x is the piece to be made as circle means the shape, this is shape is called x, that shape is nothing but 2 pi r. Why 2 pi r? Means circumference of the circle equal to x. So I am going to cut the wire, I am going to make us a circle. So circle means that length of the wire will be on circumference of the circle. So our circumference of the circle equal to x. So we need to write that the circumference of circle equal to 2 pi r, that is equal to x. So now what is the value of radius r equal to x by 2 pi, r equal to x by 2 pi. Similarly, what is the length of the piece to be made as a square, that is 28 minus x, that is nothing but circumference of the square. So circumference or perimeter of square we can consider. So perimeter of square equal to, we can consider as, that is side perimeter of square equal to 4a, so that I am writing as here. So 4 into a, that is equal to, we can write as 28 minus x, that is remaining piece. So what is the value of a here? A equal to 28 minus x divided by 4. This is the value of a now. So now I found the value of r, I found the value of a. So from these two I can find the area of circle and I can find the area of square. Then finally we can combine both area, that is called combined area of the circle and the sphere, square. So now combined area equal to we can take it as a in terms of x equal to area of circle, that is pi r square, plus area of the square, that is equal to a square. So substitute the values now. Pi r square means pi into r square value equal to x by 2 pi whole square, that is x square divided by 4 pi. Similarly, side a square equal to 28 minus x by x whole square by 4. So that will be 28 minus x the whole square divided by 16. This is the combined area of the two figures. Now this combined area to be minimized. So I need to find the critical point. So finding first derivative. So a dash of x equal to, we can cancel these two. So x square by 4 will come. Differentiation of 4 pi square, x, one of the pi will cancel. So x square by 4 pi will be there. So differentiation of x square by 4 pi equal to, with respect to x equal to 2x divided by 4 pi. 2x divided by 4 pi plus differentiation of 28 minus x the whole square by 16 equal to 1 by 16 is constant. Differentiation of 28 minus x whole square equal to 2 times 28 minus x into minus 1. So this is the first derivative. So you can simplify here, it will come as 8. Here also you can simplify, it will be 2. So a dash of x will be x divided by 2 pi minus 1 by 8 into 28 minus x. So if I want to find critical point, so if a dash of x must be equal to 0, so a dash of x equal to 0, this implies one of these things will put right side. So x by 2 pi equal to 1 by 8 into 28 minus x. We can cancel one time, here it will come 4 times. Cross multiply 4 here and pi here. So we will get 4x equal to 28 pi minus x pi. So the minus x pi will come this side. It will happen 4x plus x pi equal to 28 pi. So what is the value of x? X equal to 28 pi divided by pi plus 4 or 4 plus pi. This is the value of x. So x value nothing but critical point. Critical point I found now. So next I need to find the second derivative and then I need to substitute the critical point in the second derivative. So find second derivative for this function. So we will get a double dash of x. So a double dash equal to differentiation of x by 2 pi equal to 1 by 2 pi minus 1 by 8 is constant. Differentiation of 28 minus x equal to minus 1. So adding this we will get positive values, nothing but 1 by 2 pi plus 1 by 8. It is clearly greater than 0. So second derivative it is greater than 0, or we can substituting that x value also, x a double dash of 28 pi divided by 4 plus pi. that also will be greater than 0. So a double dash is greater than 0 means we can clearly say that a of x is minimum at the point x. So a of x is minimum at x equal to 28 pi divided by 4 plus pi. So at x equal to 28 pi by 4 plus pi, it is minimum. So what about the another value? Another value means we have to find that this is the piece to be made as a square circle, and we have to find the piece to be made as a square. The square is nothing but 28 minus x. So length of this square or length of this piece, length of another piece or second piece, length of another piece equal to 28 minus x. So subtract with 28 here. So 28 minus 28 pi divided by 4 plus pi. So taking LCM, 28 into 4 we have to multiply, 32 remaining 3. So 112 plus 28 pi minus 28 pi whole divided by 4 plus pi. So cancelling these two, we will get 112 divided by 4 plus pi. So this is the dimension length of the second piece, that is equal to in meter. This first piece also should be in meter. So the first piece means the piece to be made as a circle equal to 28 pi by 4 pi, 28 pi by 4 plus pi meter. Similarly, the second piece to be made as a square equal to 112, that is 112 divided by 4 plus pi meter. Clear? Next question number 23. Question number 23. Prove that the volume of the largest cone that can be inscribed in a sphere. So actually there is a sphere given. Sphere's radius also given, the radius equal to r. So we can write that radius of the sphere. So radius of sphere equal to capital R. So that largest cone that can be inscribed in a sphere. So a cone is inscribed in a sphere. So this is our cone. That cone we can take consider names. So we can taking the cone A. This is P. This is my Q. So this center I can take it as O. Now I can connect this center here. So O with that A. So center of the circle, center of the radius equal, center of the sphere equal to O. This is A. So this length will be R. So now we can consider the radius of the cone. So from C to Q. So radius of cone equal to, we can consider CQ equal to small r. Now what is the complete question? So a sphere is there. Inside the sphere we are drawing here, we are taking a cone. That cone is the largest cone whose volume equal to 8 by 27 of the volume of sphere. So actually what I need to prove means, what we need to prove, volume of cone equal to 8 by 27 times volume of sphere. 8 by 27 times volume of sphere we need to prove. So what to be maximized? It is largest cone. Largest cone means volume of the cone should be maximized. So we have to maximize the volume of cone. Maximize the volume of cone. Now solution. Come to the solution. So complete this diagram. So this from O to C, I don't know the value, that I am taking as X. So I can take this length. This length is nothing but same as capital R because it is the radius of the sphere. The CQ I have taken as small r. Clear? So these are the, and similarly height of the cone, height equal to AC. This height of the cone, that is AC equal to, I am considering as H. Height of the cone equal to, I can consider as H. This equal to H. Now come to the question. So what we have to maximize, we have to maximize the volume of the cone. So before finding the volume of cone, we will write the dimensions. What are dimensions given? So radius, given that radius means we can consider OA equal to or OQ equal to capital R, that we have written radius of the sphere. Similarly, the radius of the cone equal to small r, that is CQ. So CQ equal to small r, and I don't know the value of this length OC. So let OC equal to X. OC equal to X. So we are seeing a right angle triangle here. This right angle triangle shape OCQ. So drawing separately OCQ. This is a OCQ right angle triangle. This length equal to X. This length equal to R. This length equal to capital R. Now what is the value of, what is the relation between them, these three, that is this right angle triangle? So I can relate them three. So from right angle triangle or from triangle OCQ, what is that? We can use Pythagoras theorem. So r square equal to x square plus r square, x square plus r square. So from this, what is the value of the radius, that is r square equal to capital R square minus x square, capital R square minus x square. Why I am finding capital R square means I am going to maximize the volume of the cone. So what is the volume of cone formula? Volume of cone equal to 1 by 3 pi into r square into h. So I am going to replace the values here. So that is 1 by 3 pi into r square value I have written as r square minus x square. Here r square is constant because that is given already. Radius x square is not a constant, x is a variable here. Similarly, h can be written as h equal to height of the cone, height equal to r plus x. So capital R plus x. Now I have written all the volume in terms of x. So v of x equal to pi into r square minus x square, then r plus x. Next I am going to multiply these two. I am going to make as a single step. Then I will find the critical points for this equation v of x, for this function v of x. So to find the, so we have to multiply this inside and we have to make it as a single equation. So multiply this inside, we will get v of x equal to pi by 3, multiplying r square into r, we will get r cube. Next to r square into x, we will get r square into x. Next again x square into r, that is minus x square into r. Then minus x into plus, minus x square into plus x, we will get minus x cube. Next we will differentiate this with respect to x. So v dash of x will be differentiation with respect to x. So pi by 3 into differentiation of r cube is 0. Differentiation of r square into x will be r square, minus differentiation of x square into r will be 2 into x into r, minus differentiation of x cube will be minus 3 times x square. This is the first derivative. So we have to find critical point. So first derivative equal to 0. So v dash of x equal to 0 means this implies this pi by 3 into r square minus 2x into r minus 3x square equal to 0. So I need the value of x. So I am going to use the quadratic formula to find the value of x here. So pi by 3 will come this side, it will become 0. Then this can be written as, I am going to write this as equal to 0. So r square minus 2xr minus 3x square equal to 0. So we need to factorize this. So how to factorize means, we can factorize this quadratic polynomial. It is quadratic polynomial in r square. So it is r square, r and constant term. So our a value, we can use the middle term splitting method to find that. So what is the constant term? That is minus 3 into x square. So if you are multiplying two functions, means we should get minus 2xr or minus 2x we need to get, because this is constant, this is So this is the coefficient of r here, this is the constant term. So I'm multiplying 2 means I need to get minus 2x. So I'm writing minus 2x, minus 3x into plus x. So minus 3x into plus x will be minus 3x square. Minus 3x plus x means I will get minus 2x. So I am going to write here. So r square minus 3xr plus xr minus 3x square equal to 0. So what is common here? R is common. Remaining will be r minus 3x. Here what is common? X is common. So x will be taken, remaining r minus 3x equal to 0. So combining what is common these two from these two, r minus 3x into r plus x equal to 0. Here r equal to 3x will come. Second case r will be equal to negative of x. Negative of x will not be possible because x is a positive value. It is impossible. So it is impossible. So I am writing, I am taking only the value r equal to 3x. So what is the corresponding value of x here? X equal to r by 3. So this is the only critical point, x equal to r by 3. Next I need to find the v double dash. I need to substitute the x value in the v double dash and check whether it is maximum or it is positive or negative. We need to prove that the largest cone, the volume should be maximum. Volume should be maximum means that we are substituting into v double dash, that should be less than 0. So find second derivative. Find second derivative v double dash of x, that is equal to outside will be pi by 3. So differentiation of r square is 0. Here differentiation of 2 into x into r, that is minus 2r is constant. Differentiation of x equal to 1 minus differentiation of 3x square equal to minus 6 into x. So I can take minus outside, that will be minus pi by 3 into 2r plus 6x. 2r plus 6 into x. So substitute the v double dash of r by 3. X in the place r by 3. We will get minus pi by 3 into x in the place r by 3 means here it is 2r. 6 into r by 3. We can cancel this. Inside will be 2r. So totally 2r plus 2r, 4r. 4r pi by 3. That is minus 4 pi r divided by 3. It is clearly less than 0. So v of x, v double dash of r by 3 is less than 0. We can say that v of x is maximum at x equal to r by 3. So x equal to r by 3 means I need to show that the volume of the cone equal to 8 by 27 times volume of the sphere. So what is the volume of cone? Volume of cone already we have written. So v equal to pi by 3 r square minus x square into r plus x. So this I need to substitute the value of x here. So substituting, we will get pi by 3 into r square minus capital R square by 3. Here also r plus r by 3. We will simplify this. So simplifying that, so volume of cone. So volume of cone equal to pi by 3 into r square minus r square by 9 will come. I have written 3 square 9 will come. So because x square value means r by 3 whole square, that is r square by 3 square, that is 9. Then adding this means we will get 4r by 3. 4r by 3. So simplifying here, so what will come? Pi by 3 into 9r square minus r square, that is equal to 8r square by 9. Similarly 4 into r by 3. So I need 8 by 27. So 8 is available. 8 I can take outside. 27 means 1 of the 9 into 3, 27, that I can take outside. Remaining will be pi into, here it is r square are available. So pi r square and one more r available. So it will be pi r cube. Similarly denominator will be 4 available, 3 available. So 4 by 3. So that is equal to 4 by 3 pi r cube. 4 by 3 pi r cube is nothing but volume of sphere, volume of sphere. So I have proved here volume of cone equal to 8/27 times of volume of sphere. Clear? Thank you. Remaining question 24 onwards we will see next class. I think only 3 questions are available, 24, 25 and 26. After that we will move to the second volume integration chapter. Thank you.